I'd like to thank you for listening in on our discussion today on detention planning, specifically using LiDAR for value-added flood damage reduction analysis with relation to planning where you can build detention facilities in the landscape. My name is Zach Hermann. I'm a professional engineer working for Houston Engineering out of our Fargo, North Dakota office. I've done a lot of this detention planning effort scale within the Red River Basin on the Minnesota side, as well as over on the North Dakota side of the Red River. The next thing we're going to be talking about is how LiDAR can be used for prioritization of restorable wetlands across a given landscape. Now, once you get out of the lake plain and out of what we call the beach ridge in the Red River Valley, you have a lot of kind of old marshes that used to exist in the landscape that back in the many years ago, probably 50 plus years ago, most of them were actually ditched out to drain to attempt to farm the bottom of those basins. And basically what we're trying to do, you can see this is actually a photograph of one of those particular sites, but if we take a look at that from more of an aerial view, this is a photo depiction of the site. This is actually what you were looking at in the photo on the previous slide. The photograph was taken right here looking down into the site. So basically what we're trying to do, if we overlay the LiDAR information, it makes it even more apparent. This is the low area here, the presence of the pre-existing wetland at this location. You can see the ditch that was constructed to drain this particular wetland traveling through here. So what we're trying to do is basically restore the landscape to a pre-ditch condition so we can identify where these particular basins are in the landscape. We're basically using the hydrography that's derived from the hydro DEM to establish where those ditches exist. Once we establish where those ditches exist, we can pinpoint where these pre-existing wetlands may have been on the landscape. So if we have the pre-existing wetland location as well as the hydro DEM where we've accounted for all the reconditioning and all the culverts and bridges and things of that nature across the landscape, we can then take that information and relate it to what the drainage area is to each one of these potentially restorable wetlands in the landscape. So this next slide here illustrates what is the drainage area to each one of these particular wetland complexes or potential pre-existing wetland complexes in the landscape. And one of the big concerns from a natural resource standpoint is really trying to minimize the bounce on these particular structures, especially during breeding seasons for waterfowl and that type of thing. So one thing that this does allow you to look at, since you have such a high resolution elevation data set, and you have a drainage area that's pretty precise, that you can really derive a really realistic computation of what you think the volume of runoff is coming to site. You can relate that to things such as what's the available storage under scenarios, say 1 foot of bounce, 2 foot of bounce, 3 foot of bounce, that type of thing, and then take a look at, maybe you can store, maybe your prioritization is wetlands that provide 3 or more inches of runoff reduction potential while minimizing bounce, or in flat topography it may be more of a function of providing storage for 3 inches of runoff while minimizing the footprint area increase, or whatever the case may be. By incorporating the hydro DEM and trying to pinpoint these locations, it really lends itself to meeting criteria, not only from a flood damage reduction standpoint, but also what's going to best make use of that as kind of a dual purpose project, so you can get natural resource enhancement benefit, water quality benefit, all those other good things that come along with building a retention project. So at this point, I would just like to wrap up the presentation, say thank you for listening in on the detention planning presentation that I've just given. If you have any questions, again, my name is Zach Hermann. I work with Houston Engineering out of our Fargo office, and my email is on the screen. So if you have any questions, just feel free to let me know. Thanks.